Hi Year 12s, this is your Circles TLF and it's the last question, the challenge question. Okay, so we have a circle, we're given the equation and we're calling the centre C. We have to show that. So when we see show that, that means we've got to justify our answer. Show that no part of the circle lies above the x-axis. So it'd be a great idea to sketch it. You could probably do it just by figuring it out, but if you wanted to use your graphical calculator, if you go to the conic graphs menu, okay, and then if you scroll down, you'll hopefully see that one of the options is a circle. So it's got x minus the x coordinate, so that would be 2, okay, and y minus the y coordinate, so I need to put -5 in there, and then the radius is 5, the square of 25. Okay, so I'm going to draw it. Now mine's nice and square, and that's because when I went to view window, I chose square and I wanted it. I had part of the circle in already. Okay, so let's just draw that again. So we can see here that the circle does touch the x-axis, but it doesn't lie above it. Okay, so I'm going to sketch that because that's going to help me with what I'm talking about. I think I'm going to start by drawing the circle. Okay, I know that the centre is at 2, -5. Okay, and then I also, if I draw my y-axis and my x-axis there, okay, I know that the radius, is 5, so I can go anywhere. I can put 5 there, but it's particularly useful to put my radius of 5 going straight up. Okay, so if I point out that the y coordinate of the centre of C is -5, okay, and the radius is 5. If I do -5 plus 5, that gives me 0, which means the y coordinate is on the x-axis. Okay, so that is a point, that's the highest point in the circle. Okay, so that's one way of doing it. That was the way the mark scheme was expecting. You've got a mark for getting the -5, got a mark for getting the 5, and then by sketching or trying to explain, okay, that the circle reaches the x-axis but doesn't go above it, then you get your third mark. So I think I need to justify slightly more, put a conclusion. So no points on the circle lie above the x-axis. Okay, so that matches what the question was saying. Okay, now there is a different approach that a few people took, so I'll just show you on here. So another way of thinking of it, so I'm going to, oh gosh, be brave, sketch the axes before my circle this time. Okay, is I want to look for points of intersection with the x-axis. All right, because if I've discovered there are no points of intersection of this circle with the x-axis, then as long as at least one point lies below the x-axis, none of it will lie above. Okay, so the x-axis has equation y is 0. So we're going to substitute y is 0 into the circle equation. Okay, so I've got x minus 2 squared plus 0 plus 5 squared is 25. All right, and so if I work that out, that's 25. So I end up with x minus 2 squared is 0, which has only one solution. X is 2, so the x-axis is a tangent to the circle. Okay, and C has y coordinate -5, which is less than 0, so the whole circle must lie below the doesn't lie above the x-axis. Or rather, no part of the circle. Okay, so hopefully that makes sense as an alternative option. Okay, let's look at part 2. So the point P has these coordinates and lies inside the circle. Okay, so somewhere inside the circle on our little picture, somewhere in there. So that means that distance from the centre to that point has got to be less than the radius of 5. So when we look at this equation, the coordinates 6 and k are going to satisfy that equation, but less than 25. If it was equal to 25, it would lie on the circle. If it was bigger than 25, the point would lie out the circle. But because it's less than, it lies inside the circle. So we've got, our equation was x minus 2 squared plus y plus 5 squared is, and we want to put less than 25. So let's substitute 6 instead of x and k instead of y. Okay, and then we just need to do some expanding. So that's going to be 4 squared, which is 16. And then k squared plus 10k plus 25. Let's subtract the 25 from here because we know that we like having quadratics with zeros. And do a bit of tidying. So we've got k squared plus 10k. This will make 0, so we've still got a plus 16 is less than 0. Right, so this is a quadratic inequality. Remember, we always sketch these. So it's a happy face. And what we want to know is where does it cross that x-axis? So we can factorize. Again, you can use your calculator to solve this, but it's not too bad. It's all positive. And 2 times 8 is going to do it. Okay, so that makes 16 and they add to make 10. So that means my cutoff points are -2 and -8. Okay, and we're interested in the part of the curve that is less than 0. So we're looking at this part here. So it's the in-between bit from -8 up to -2. So we can write -8 less than k less than -2. Not or equal to, because that would be lies inside or on the circle. We want just less than. Okay. Right, the last part of the question, we have to prove that this line does not meet the circle. Okay, so that means they will have no points of intersection. So if I drew that line, that's really, its y is a half x, isn't it? So if I try and draw it on here, it's going to be like this. I'm going to show that there are no points of intersection between that line and the circle. So we just try and solve them simultaneously. So we're going to, because we have a non-linear equation here, we're going to use substitution. So wherever I see an x, I'm going to put 2y. If I rearranged it and did y as a half x, I'd have fractions, which is a mess. Okay. So instead of an x, I'm going to put 2y. Just try and get the page right. Okay. So it was x minus 2 squared plus y plus 5 squared equals 25. Okay, and so now we put 2y minus 2 all squared plus y plus 5 squared is 25. So this is going to be quadratic in y. I'm going to expand and make it equal 0. So we get 4y squared minus 8y plus 4 plus y squared plus 10y plus 25, and we're going to subtract this 25 so that we end up with a lovely 0 on the right hand side. So if we count this up, we've got 5y squared plus 2y and then plus 4 is 0. So that one's a bit tougher. I'm going to make my calculator work it out. So go menu and go down to the algebra menu. So that's equation menu, sorry. There we go. Right, I want to solve polynomial, degree 2. My coefficients are, hang on, 5, 2, and 4. Okay. Oh dear, that doesn't look good, does it? Have I got Mr. Minus off? No, I think I'm happy with that. Okay, oh yes, so that, sorry, this is good news, isn't it? So this tells me I haven't got any real solutions. So I could attempt to solve it and write the working out. So I'd have to use either completing the square, which looks awful with that 5, or the formula, which is a palaver, or better still, to show that we have no solutions, no real solutions, we can use the shortcut, which is the discriminant. So we've got b squared minus 4ac, b is 2, a is 5, c is 4. So from that, we've got 2 squared minus 4 times 5 times 4, and that turns out to be, so 4 take away, good heavens, I'm going to do this on here, my brain's given up, minus 4 times 5 times 4, minus 76, there we go. Right, so that's definitely negative, therefore no real solutions, which means no points of intersection. So in the words from the question, 2y equals x does not meet the circle. Okay.